Graph the given functions f and g in the same rectangular coordinate system. Select integers for x starting with -2 and ending with 2. Once you have obtained your graph, describe how the graph of g is related to the graph of f. Okay, we're not going to camp out in this section because later on in this chapter, we're going to be talking about transformation and how to transform uh, certain equations and what you would have to do. But let's look at the first example A. You have f of x is equal to x. I need you to understand that f of x equals to x is the same thing as saying y is equal to x. Here we have a linear function, a linear equation, and then replacing y with f of x, this becomes a linear function. So what I did here, especially to save time, I graphed the f of x function for you. That's been graphed. It says here we would create a table. Here's our f of x equals to x. We created xy table from -2 to +2. And we plug values in for x and plot. So the f of x is given. It says here now I want you to graph the g of x. Create a table. Plug values in for x, starting with +2, ending with -2. And find y. Now, just for time's sake, what we're going to do, we're going to enter this information into our calculator. Okay, so, but you can also substitute this without the calculator. Plug -2 in for x. -2 minus 3 gives us -5. Then substitute -1 in for x. -1 minus 3 gives us -4. Then 0 in for x. 0 minus 3, we have -3, and we can keep going. Then 1 minus 3, that's -2. 2 minus 3, that's -1. Now that's working this out, okay, by hand without a calculator. Now if you want to, let's go and plug in x minus 3, okay, and press your table feature. So second and graph, and then you can see your values for -2 through +2. Okay, so let's plot those points there. -2, -5, -1, -4, 0, -3, 1, -2, 2, -1, and then connect. And what this is asking you to do is to describe how this graph of g of x relates to the graph of f of x. What do you notice? Both are linear, they're straight lines, but the difference is if you notice that the g of x graph moved down by 3 units. Every point moved down by 3 units. Okay, so that's how we would describe the graph. Now for B, we have f of x is equal to the absolute value of x. Okay, so here's your table. Here's the f of x. See, I drew that for you. So you don't have to worry about trying to draw that one out. Let me fix this here. All right, the absolute value of x. Here's the xy table. So we're going to get 2, 1, 0, 1, 2. Now, if you notice, these are the points that's on this absolute value, our V-shaped graph. Now it's asking us to graph g of x equals to the absolute value of x plus 1. You can put this information into your calculator, or we can figure this out by using pen and paper, our head here. So the absolute value of 2, negative 2 is 2 plus 1, that gives us 3. The absolute value of negative 1 is 1 plus 1, that's 2. The absolute value of 0 is 0 plus 1 is 1. Then the absolute value of 1 is 1 plus 1 is 2. And then the absolute value of 2 is 2. Then add 1, we have 3. So describe the graphs. What do you notice change? What changed when we added the 1 to this absolute value of x? So let's plot it so that you can see it. So we have negative 2, 3. We have negative 1, 2, 0, 1. We have 1, 2. And we have 2, 3. Still a V-shaped graph, but what happened? Our g of x graph moved up by 1 unit. There we go. So this is going to be an introduction to transformation. Given the original graph, starting adding numbers to that graph, how does it translate up, down, left, right, reflects about the x-axis, y-axis? We'll talk about that later on. But let's go to another example that's not going to take us that long to do. Using the vertical line test, given a graph, how do you determine if this is a function or not? It says here, if any vertical line intersects the graph of a relation at more than one point, then the relation graphed is not a function. Meaning, I'm going to draw at A, we have a linear equation. I'm going to just draw a vertical line. As I draw this vertical line intersects this graph at just one point. So then this would be a function. Look at B. The vertical line, if I just draw a vertical line, it intersects. This is a parabola just once. That's the parabola is shaped upward. So we would say that this is a function. C. We have a parabola. This time it is going to the side. Okay, that means the y is being squared. But when I draw a vertical line, I want you to see how many times does this vertical line touch the graph. Here is 1, here is 2. We would say that this is not a function. How about D? Is this a function or not? It's not a function. Example 6. So we have a graph. Okay, let me put this in, fold this up for a second so we can see this graph here. It says use the graph of G to find G of 2. So my question to you is asking us to find G of 2. Is this 2 an independent variable or is it a dependent variable? It's an independent variable, meaning that this is our x value. So we want to find the y. So let's go to the graph. Let's look at our points. This point here is negative 6, 8. That's not what we want. Here's another point at the origin, 0, 0. Then we have a third point that's identified at 2 comma negative 4. So we have an x value of 2. That's our independent variable. Therefore, our dependent variable would be negative 4. So what you would have to do is look on the graph, find where you have an ordered pair and the x value here is 2, and then identify from there from the ordered pair, identify the y value.